Hello students. Today the lesson is exploring graph of rational functions. And what we'll be doing in this lesson is exploring some features of the rational functions. So the first function is, the question is state the restrictions and then sketch each of the following. So first question is question number 1a is the function is f of x equals 1 over x, right? So here, first we have to state the restriction. And we know that when it comes to the restrictions, here the denominator is, we have only one term in the denominator, which is x. So the restriction is x is not equal to 0. Okay, now to graph it, what I did, I just fill in my table of values, right? I took x as 0 and towards some negative and positive values, and then I calculated my function's value at these points, right? And now if I sketch these, the graph, I have to look at the points on the grid. So if you start from 0, and you know that x cannot be 0 because my function is undefined at 0. Okay, now if I plot, I start from positive 0.1, or it's better if I start at 1. So when x is 1, my y value is also 1, right? So that's the point. When x is 2, my y value is 0.5. When x is 3, my y value is basically 0.3. So it will be here, right? Okay, now if I just look at, if I go closer to 0, I cannot take 0, but I can go closer to 0. So if I take 0.1, my y value is 10. So 10 is not on the graph, but you can suppose the 10 is up here, right? That's the point. When my x value is 0.5, the y value is 2. So that is 0.5. The x value, that's 0.5. The y value is it's 2 here, right? So this is the point. So if I use these points and I graph it, my graph will look like that is here. Right? Okay. And now I just look at my negative values. So if I start from negative 0.1, my y value is negative 10. So negative 0.5 and negative 10, suppose negative 10 is here, right? Okay, when it is negative 0.5, my y value is negative 2. So this is the point. When x is negative 1, y is also negative 1. So that's the point. When x is negative 2, it's negative 0.5. So that's the point. And when x is negative 3, it's negative 0.3. So these are my points. And then I graph it. So when I graph it, I'll do the same thing as I did. Okay. So this is the graph of the function. And if you notice that my graph is not going to touch x-axis, right? And it's not going to touch the y-axis, right? So when it comes to a line that your graph never touches, that is called the asymptotes. Okay, so here in this function, in this graph, which is a graph of a rational function, we have two asymptotes. One is horizontal and one is vertical. So if you just look at the horizontal line, my graph is not touching, that's the line, right? And that is x-axis. And that is horizontal asymptote. So what's the horizontal asymptote is, I can just write horizontal asymptote, right? So that's the horizontal asymptote. The equation of x-axis is y equals 0. And if I just look at the graph here, so my graph is not even touching the y-axis. So here y-axis is basically my vertical graph, right? Vertical asymptote. So what I will do, I just draw the line on the top so that you can see that it's a horizontal and the vertical asymptote. So the vertical asymptote is x equals 0. That's the equation of, that is x-axis, and that is y-axis. So this is how we can write the equation of asymptote, and this is how the graph will look like. Now moving on to the next question. It's again the rational function, but here my restriction is x, the denominator is x minus 3, so the restriction will be x is not equal to 3, right? Now to graph it, I'll do the same thing. I fill in the table of values and then I graph it, right? So obviously the graph of this function will be different than we have already graphed. So here, if I just plot my values I have, here, let me start at 3.1. At 3.1, and you know that is 3, right? So 3.1 is very close to 3, and my y value is 10. So again, the 10 is not here, so that's my point. Okay, and then when I take 3.5, my y value is 2. So that's the point. When I take x as 4, my y value is 1. When I take x as 5, it's 0.5, right? So my graph will look like, if I graph it, it will be something like that. Okay, now I'll graph the values that is to the left of 3. So I start from 2.9. So at 2.9, which is almost here, 2.9, my y value is negative 10. So negative 10 is, again, say the negative 10 is here. And then I have 2.5. 2.5 is negative 2. So the at 2.5, it is negative 2. So that's the point. At 2, it is negative 1. So at 2, it's negative 1. Then at 1, it is negative 0.5. So at 1 is negative 0.5. And at 0, it is negative 0.3. So it's very close to the axis. Then at negative 1, I have negative 0.25. So this keeps becoming closer and closer to the x-axis. At negative 2, it is more closer, negative 0.1, right? So if I graph the other portion of the other portion, it will be like, I mean, it's not touching x-axis, so the graph will be like, it's like that, right? So that is my graph. Now if I look at the asymptote, you can see that my graph is not touching which line. If you draw the vertical line, the vertical line is basically this line here, because you know x cannot be 3, and this is the line x equals 3. So that is my vertical asymptote, right? And when it comes to the horizontal asymptote, is again the x-axis. So that's my horizontal asymptote, right? So I'll write the equation of my horizontal and vertical asymptote. Vertical asymptote is always where the restriction is, right? So x is not equal to 3, so it means my vertical asymptote is x is equal to 3. And when it comes to the horizontal asymptote, it is y equal 0, right? Which is the equation of x-axis. So this is the graph of a rational function, and then we have to write the equation of the vertical and horizontal asymptotes. Okay, now the next question is, you are given two different functions. State the restriction and then graph. Do you think the functions are equivalent? Okay, now first we have to state the restrictions. So for this, for f of x, you can see that the restriction is x is not equal to 2. But for g of x, I need to simplify it first to figure out my restriction. So I know I can factor the denominator. So it will be x plus 2 divided by x plus 2 and x minus 3. And now I will write the restriction. So x minus 2, right? Let's fix that. So it is x minus 2, right? And now if I write the restrictions, x is not equal to negative 2 and x not equal to 2, right? So these are my restrictions. But you know that I can also simplify it because I have a common factor. So I can cancel that out, and my function will be 1 over x minus 2, right? Okay, now if I have to graph it, on my f of x, my vertical asymptote is at 2, right? Because it's saying x cannot be 2. So if I draw my vertical asymptote, the vertical asymptote is at 2. So I can graph it here. Okay. And the horizontal asymptote will be at y equals 0, right? The x-axis. And if I graph it, you can make a table of values, but if you graph it, the function will look like the same as we did in previous questions. It will be like that here, and then it's like here. So that is the graph, right? Now, for this function, which is g of x, the final equation for the function is same as the first one, like f of x, but you can see that the restrictions are not the same, right? So x cannot be -2 and x cannot be 2, right? So and but I have a common factor at x equals -2. So if my function, if I do on here, if I do g of -2, I will get 1 over -2 minus 2, which is 1 over -4, which is -0.25, right? Okay, when I graph this relation or function, I cannot take, that x cannot be -2, so I cannot take x as -2. So when x is -2, my y value is -0.25, right? So this cannot be a point on my graph, right? So what I will do, if the graph will almost look like here as f of x, but the thing is, I cannot take x as -2. So when I graph that, so my asymptote, horizontal and vertical, they will be same. So that is my vertical asymptote, and that is my horizontal asymptote, right? But this point cannot be on my graph. So because x cannot be -2, so I have to locate that point. When x is -2, y value is -0.5. So this is the point. This point cannot be on my graph, right? So now when I graph the function, it will be like that. It will just touch that, but it won't cross that. My graph will be like that. Oh, not like that. I mean, here I have to fix that. It will be okay, just like that. And on the right of 2, it's like that, right? Now this graph, the graph of g of x has a hole at that point, right? So it means whenever you have a function, a rational function, which has a common factor in the denominator and the numerator, at that point the graph has a hole, right? And f of x and g of x, they are not equivalent because the restrictions are not the same, right? So for a function, if the restrictions are not same, though the functions look same, they are not equivalent. Okay. The next question, which is the last question, is identify the rational function whose graph has a horizontal asymptote and 2 vertical asymptote. Graph the function. Okay, here you have to just use that information to graph a function, right? It is saying it has 2 vertical asymptotes, right? And I told you the vertical asymptotes are at the restriction, so we can just make up our function. It can be any function, it can be different function. So if I have to give 2 vertical asymptote, I have to write 2 restrictions. Say I'm writing x is not equal to 2 and -2, right? It means I should have x minus 2 and x plus 2 in the denominator, right? On the numerator, I can write in anything. Just make it simple, keep it 1, right? So that's my function. Okay, and the horizontal asymptote is x-axis again here, because 1 over any number is never equal to 0, right? So the value of that function can never be 0 because it's 1 over something. Okay, now when I graph it, so I have to draw my asymptotes first. So when I draw my asymptotes here, which is 2 and negative 2, so, and these are the vertical asymptote at negative 2, that's my one of my vertical asymptote, and the other vertical asymptote is at neg 2. So two vertical asymptote and negative at negative 2 and 2. And now if I just before I graph that, I can simplify this function, so I can write it as x squared minus 4, right, if I multiply these two. Okay, now if I have to graph it, because this is not a simple function, I can make the table of values here. So I plug in some random positive and negative values. Okay, so when x is 0 here, if I plug in 0 here, x is 0, it will be negative 1 over 4, so it will be negative 0.25. When I take x as negative 1, it will be negative 0.3. When x take negative 3, it will be 0.2. When I take x as negative 4, it's 0.08, right? And now I have to graph it. So if I start from 0, right? If I start from 0, at 0, my y value is negative 0.25, which is almost here, right? When x is 1, it is negative 0.3. It's a bit here, right? And when x is negative 1, it's the same, negative 0.3, right? And you know that my graph cannot touch the vertical asymptotes. So here, for this portion, the graph will be like that. I mean, it's just passing through the points. It's approaching to the asymptotes, but it's never going to touch the asymptote. Okay, now I have to graph at the right of 2 and the left of 2. So at 2, I have an asymptote. So if I just look at 3, at 3, my y value is 0.2, which is here. At 4, it's more closer to the x-axis. If I take a point here, my y value can be here, right? So the graph will be here. Okay. Similarly, if I use negative 2, negative 3, negative 4, and I graph it, I will get the points here. So at 3, it is negative 0.2, and then I say 0.4, and at here, it will be something like some value here, and I will graph it. It will be like that. So that is a graph of the function, which has two vertical asymptotes, and the horizontal asymptote is x equal 0. So if I graph my horizontal asymptote, let's graph using the, okay, yes, that is my horizontal asymptote, right? So if I write what's my horizontal and vertical asymptote, so horizontal asymptote is y equals 0, which is the equation of x-axis, and the vertical asymptote is, I have two vertical asymptotes, x equals 2 and x equals minus 2, right? So whenever you have two vertical asymptote, the graph is quite different when if you compare it in the first question and the second question we did, where we have only one vertical asymptote. And that's it for this lesson. Thank you so much.